Hey guys, I'm Zalil. Nice to see you again in Project-3. I am so happy to see you again. I hope you liked my previous projects and now you are on Project-3. So today I want to create a project which is a very important step in data analysis, which is data cleaning. Why it's very important? Because if you don't clean your data very well, your analysis might be wrong and you can make a wrong decision. That's why data cleaning is very important. And in real world scenarios, most of time you spend your time on data cleaning, because in real world scenarios there are many messy data, and you need to tied up your messy data sets. So I decided to create project for that reason. Of course, maybe we can't cover whole things about data cleaning in this project, but it will give you an idea how you can approach your projects and other projects, because in for each data sets it requires different ways to clean your data, but generally the by coding ways may be similar. So let's continue and see, maybe in the future I can make some different kind of data cleaning. So but today I want to continue this movies data set, and let's clean this data. Maybe we'll use a clean version of our current data for our next projects. So guys, the first, let's take some first steps in here. Let's import pandas, numpy and ast modules and libraries for our project. It may take some time to run maybe. And let's import our movies metadata to our code editor. Now let's see the head of our datasets. So guys, as you see, what we have 5 rows, actually not 5 rows, main rows, it's just head of our dataset, and we have 24 columns in our datasets. Let's see the information. Okay, let's check our information in here. For example, I always first check the date. What is the type of data? It's written in here object, but actually it must be in date format. I mean the whole this process. I want to show you whole process, how to use information about these data sets. Okay guys, it's just an idea. For example, in here in 5 we have id, it's object, but actually it must be integer values. We will correct these all things with this data. Now let's go to up and check our columns, what we have in these columns. Let's check, for example, belongs to collection genres. Here guys, the very messy data, because it's all JSON format. Probably they take this data from by help of API, but in here we interested, for example, Toy Story collection, not just this ID name. It's so messy data. We can see it in here also in genres. It's a kind of, it looks like a list of dictionaries. So we have some columns in here. It's not important. We need to drop them, or and so on. For example, spoken language, again, we just want to name to as English, not these messy data in here, and so let's take some steps, some approach how we can clean it. For example, let's look genres column, and first on of it, guys, it is stringified. It's a list of dictionary, but it's like an object. So we'll convert it to dictionary format, and we take these names: animation, comedy and family, to make very clear when we see when we look at the column. So okay, also we can look belongs to collections, one of the first row of our column. As you see, guys, it's a very big, long, very long dictionary, string dictionary. It's a dictionary in here, but in string. Okay, firstly, let's dropping irrelevant columns in here again. Let's see information. We see before we have here we have adult. Maybe who can watch this? Maybe we don't need this. For example, we have IMDb ID and actual ID. Maybe we don't need IMDb ID. Or we have original title, and I think we have another title in here. Original title, and let's maybe in here we miss it out. Okay, let's see what's adult in here. Okay, maybe it's for adult or not, true false. Maybe we don't need this column. Of course, it depends on your choice. Maybe you need you for your analysis, but for me, I don't need it. So I decided to drop our columns, adult columns in here, and in place true. So let's drop it. Then we don't need IMDb ID. Also, I want to drop it. Maybe I don't need original title. Also, in here video, I think it is short video. Maybe it's something URL you can go and watch. For now, we don't need this. And home page, maybe you can drop or not. It depends on you. I think maybe we can keep it. And let's go down how to handle stringified JSON columns. Firstly, okay, we are going to take a look generous. Okay, in generous columns, as you guys, it is a list of dictionaries inside. As we said before, we are looking actually the name in here, which genres our film is. So let's also see whole one of our genres in here. We have dictionary in a list. So let's find out is null sum. Okay, we don't have null values in here. So what we are going to do here, firstly, let's check out. We are using apply lambda function to check is a value in genus column is instance true or is instance is string or not. We are just checking that. As you see, almost whole columns are true. It means that it's a string for its type is string, but actually it's a dictionary, so we need to convert it to its actual type. After that, we'll clean these. We'll try to take names from these dictionaries. Okay, guys, that is why we are going to use same apply and lambda function in here by the help of IST literal evaluation, which is takes the string value. For example, what I mean by saying string value, it's a dictionary in string. We want to remove this string double quotes from here to make it actual dictionary. So why I'm doing that, because after converting to its dictionary, I can take these names from this dictionary. So what lambda function do it in here? In here, lambda take x is each values in generous column. Check it. If it is instance is string, if it is string, we convert to its dictionary. If it is not string, maybe some messy data, we don't know, some mix of data, we give it none value. So let's run this. and again is null sum. We don't have none values in here, so this column is so clean. So let's check our belongs to collection column in here. So as you see, obviously we have some non values in here and mixed data type probably. Let's check again true, false. For example, it looks like dictionary, but actually it's string in string type. So we'll convert again this string to dictionary type. So let's again, we are going to use a lambda function to convert this string to convert this string to dictionary, and if it's non-value and some other type of values, we are converting them to non-values. And so let's see that, guys. Okay, as you see, before it was like a string, but now it actually show us as a dictionary. So that is why we use as literal evaluation, IST, literal evaluation, which convert string value in string format to real dictionary value, because in the string it was a dictionary. We remove strings, this double quotes with as a literal evaluation method. So again, we are going to check another one, spoken language column. So in here we need to just check English. Again, I use the same format as literal evaluation. If is instance is string, we convert it to actual format, data type. If it is other type, such as maybe they mistakenly write in here float number, it will convert it to non-values. So if you don't know what is apply method lambda function, just Google it, lambda apply method. And also it is a ternary function in here. It's one line if else condition. So it's so clean, because when we use in our projects, in real work scenarios, even in interview questions, it seems obviously you know how to write clean data, guys. So that's the reason, if you don't know it, you can Google it, or maybe in the future I can make some tutorial to explain it. But mostly I focus on creating projects, which I think very important while applying the real jobs. So it runs again. And by the way, I forget to mention that in here, why I write df spoken language equal to this, to update whole columns in here. Okay, guys, if you don't make it equal to that one, it will not update. We update actual our data sets to make it in dictionary format. So again, same apply to production countries. So again, let's production companies in here. As you see in here, we can see this string, but when we call one of it, guys, let me show in here with 0 and run it again, guys. As you see, it is a string. So when you call whole column, we can notice it, but when we use take one of the value from the list, we can see it. So again, we apply same thing in here to change this data type to dictionary. So in here, what we are going to do, we are going to flatten nested columns. What I mean by saying that, we are going to do it because we take just name of from dictionary. For example, we need to Pixar Animation Studios, just this one. So flatten means that taking only the name from dictionary and write it like a string. That is simple. So let's again belongs to collection, one of the to see it. Okay, it was previously it was like a string, but it's now like a dictionary. So again, we are using apply and lambda function here, apply method in here. To x in here is, for example, that one. Take it if is instance dictionary. If it is dictionary, previously it was like a string, but now it's a dictionary. If it is not dictionary, we are making non-values. As I said before, guys, maybe we have some float integer numbers in here, some mixed data types. So that reason we want to make sure that our type in here is dictionary. So if it is not dictionary, for other type of data we give non-values to make it clean. So again, we will take with the lambda function, we will take name from this dictionary, and instead of this we will put the name in our columns and update our columns. So let's run our cell in here, and let's check our head of updated version. So guys, let's value counts drop now false. In here we have very too much, almost 95% of our belongs to collection is non-values. Maybe you think that maybe it's not good, too much values are missing, but don't worry about it, because maybe most of our films are not belongs to any collection. It's possible. So that reason, let's keep our columns in here. And you know, this the Bowery Boys total collection, maybe it's not this is type of collection in here, and our 95% is approximately our data not belongs to any collection. So as you see, guys, previously it was like Toy Story collection, but now it was like a dictionary. It's very big messy data, but now we convert it to very cool, simple and readable format. That's very nice. So I hope you understand the aim of what we did in here to make it more clear and more readable. So let's use genres in here. Again, it was previously like a string, but now it's a list of dictionaries. So what we are going to in here? We use again lambda function in here. What is it in here? By using join, for each value name I means it's like X, I is dictionaries. We have 3 I's in here. So taking each name of dictionary in here and loop through it like that in X and join them with that one. We can use a comma in here, any separator, even we use empty string, anything. So let's check it and to look on of it what we will get. As you see, guys, in here by for loop we take each names animation comma the family from 1 the X, I mean list of dictionary in here, and we use join method in here to join these names to make like a simple readable format. Look at just one line of code make our data very clean and very readable. So let's see the value counts. Okay, we have 5,000 drama, more than 3,000 we have comedy, drama, and so on. If we have one type, it just show one of them. If we have more than one, it like join them with that and write with this clear format. So let's type. As you see, guys, there is empty string in here, empty string here. It doesn't have any meaning, so not readable. So we are going to numpy to replace in generous column this empty string with non-values, and by saying in place true we update this generous column. So let's copy this code in here again, and write here to see what we have already updated. Okay guys, as you see, before it was empty string, but now we have non-values. It's more readable. That's why instead of empty string, maybe you see empty, you miss out something, but we want to mention that it's a non-value. So let's take another spoken language in here. As you see, it's very messy. Again, by same method, using apply lambda function, join the name. As you see guys, spoken language, it was like a list, so we check it is instance. Previously we used it like string or dictionary or list. It check if instance x is list true or false. If it is true, we apply this one. If it is not true, we are using numpy non-values, we give non-values for it guys. So again, let's run it and let's again check it. As you see, again we have some empty string in here. Let's reverse this empty string with non-value and in place true. Again, we check production countries in here. Again, we have JSON format data. We just want the name of country. Again, we are using same logic. Again, let's count values. We have United States of America 17,000 times. Films belongs to United States. We have empty string in here. Again, we are replacing this empty string with non-values and in place true. By saying in place true, we update values of this column. Again, check production companies. Again, messy data. Again, by using same format, we update. Again, value counts to check we have, okay, wow, we have empty rows in here is almost 11,000, 12,000. So again, we replace them with so what we have done in here, let's is non-values. Let's check. In general, we want to check how many non-values for each column we have. So belongs to collection have 40,000, almost 41,000 almost non-values. Budget doesn't have any non-values. ID doesn't have any non-values. And production companies, countries, we have in here home page non-values. For example, previously I didn't drop it. Maybe I'm going to drop it. So taglines, we have many missing data in here and so on. And now let's check our original data sets and compare what we did in here. So guys, we let's check these. Okay, for example, we have already dropped this IMDb column and so on. So some, but I forget to drop home page in here. So anyway, we just by doing that after cleaning our data to compare our original data, what we have achieved until now. For now, I think that for first part of our project, it is enough. So I hope you like it, guys, and I will make the second part of our project. So also we will have some important discussion in the second part. So keep learning together. I hope you enjoyed it a lot, and I really enjoy while creating these projects. So if you like it, don't forget to subscribe, like, and share. Thank you so much. See you Project 3 Part 2 on the next time. Thank you.